You're the one who touches my heart. Step by step, I follow you. Testing.
Hello?
Yes, YanKeen. I can wait. I can hear you. Can you hear me?
Yeah.
Okay. Clear.
Yeah, just give me some time.
Okay. Any updates?
Yeah, sure. So Monday for physics, we started the quantum physics tutorial.
Yeah. Okay. The
Uh,
quantum physics tutorial.
oh yeah.
You mean you went through the lecture?
I'm behind. I only went through like one like
Oh,
after Sunday, I went through
yeah.
like one lecture on the photoelectric effect.
This is recorded lah. Right. This is. Oh, okay. That's.
After audition ended on Sunday, that I went through on. Honestly,
Okay.
physics I'm only just keeping up. So yeah.
Yeah.
Anyways.
Okay. Okay. Understand. Tutorial. Okay then.
Math, we had a lecture on binomial. Yeah, binomial.
Oh, right. Sorry, I was thinking about another one. Yeah, good. So after DRV lah. Good. Okay then.
Yeah, so binomial. Not sure when that's gonna be finished, but today I got my new set of lecture notes, so I guess it'll be soon.
No. You still have like 4 more.
Oh, it's been like 2 lessons already.
Right. I mean,
we
after
have one on. We have one on. We have one on the Thursday. Last Thursday, I think.
I mean after binomial.
Oh
Okay. So then.
Yeah. So we did binomial on yesterday in the lecture.
Sure.
Today we have chem, right? It was just chem. No, it was. Oh yeah, sorry. Then there was chem. There was chem today. We did the elucidation question from last Sunday. The one where we spent like 1 hour, 1.5 hours just doing elucidation.
And
so
then
we went through that today, and then we finished carbon now tutorial.
Like the tutorial, did you finally get an answer or something? Like, did you confirm? Like, is it correct? Like, there's something missing.
Yeah.
Right?
I think question. What was it? One of the questions I remember is what I got answer for, and for the elucidation question, it's easier if I get it. The elucidation question. There was because we had one of the, we couldn't find one of the compounds, right?
Yeah.
Compound, I think it was let me zoom in. I think it was this one. It was aqueous bromine, yeah. Because aqueous bromine, then we assume it will have a double bond, right? So that's what I wrote here. Turns out my teacher said that aqueous bromine can also mean as a benzene ring. So yeah, I'm not sure. Anyway, so
what is K?
Yep.
Aqueous bromine cannot react with the benzene. Okay, never mind. I'm going to write it down.
She said the anhydrous condition. She said the anhydrous condition applied to the catalyst.
But this is not anhydrous one. This is aqueous bromine, right?
Yeah, like when we say like an aqueous bromine with like anhydrous AlCl sorry, LCL, LBR3 or something like that. Then yeah, she said that doesn't mean, I don't know. The evidence like BR2 equals this is like pentagonal.
Okay, never mind. I'm gonna keep that in mind, and we'll just check it out. Good. The rest are okay lah.
Yeah, then the rest is fine. Then also
Good.
I got back my PW today, so it's solid.
How is it?
Oh yeah, A. I'm feeling pretty proud about it.
I mean, I would say that as expected, but what I meant is really, I think you will be happy with it. Good. Yeah, saying that as expected means that I have full confidence that you can do those things. Good. Your team. Right. Good. Now, I don't like you hanging on a thread with physics, but this has been happening for quite some time, right? Okay. So, do you have any questions on math or chemistry?
I have one for math, but
okay,
it's DRV, and I'm like,
quickly, come, let's finish it quickly. Then I want to just go slightly ahead, right? Just help you be faster.
Let me get the other. What's question? No, that's not here. My file. Right. So. Yeah. This was sorry, you didn't read it first.
Question, right? Question 8, is it? I'm using the show me. Right. Okay. I'm using the previous Jamboard, right? Okay. Then show me the question.
Yeah. So
I believe on page 6, yeah, previous Jamboard, page 6.
Yeah. Okay. So let me start up.
Okay.
Jamboard. Oh. Okay. So this is my working so far. I'm trying to use the table again, but
only this table.
Only this table. Yeah, only this table. The rest.
Right. No problem.
I'm trying to use this table again, but I feel like I'm reaching the limits of what the table can do, because if you look at
show me the table. At least I can put it.
So the first card and the second card.
Right.
So
if the sum is if the sum of the two cards is an even number, the player picks a third, the square of the third cards. Yeah, he's obviously making it complicated, right?
Yeah.
But
right. So if I get an odd summation, which I can just get from here, right? Then I'm not sure which value I should put inside here, because it could be one or the other, right? There's only two options.
Right. Okay. Let's just say that we want to use the table. Let's just say, because at least you do a few things, right? The crosses seems right. The 3 and 5 seems right. I'm a bit confused why you don't put 5 here, right? I'm a bit confused there. 5 here, 7 here, like why don't you just okay, yeah. So let's clear that one up first. Everything which is possible to do, right? Everything which is possible to do. Because I think you're missing some, right? Okay, that would be nice, very nice. 5, and then right. Okay, then suddenly the table doesn't look so useless, right? Right?
No.
Right. So now the problem with the table is that you need a third dimension for a third card. That's annoying, right? You need a third dimension for a third card. But it's not very complicated. Now, first thing first, you notice that the value, there's a 4 here. The value 4 doesn't matter, I guess, right? That's what he's saying, right?
Yeah.
The value 4 doesn't matter.
Fact,
the value
yeah.
The value 4 and 6 doesn't matter, right? But since he's going to pick the third card, right? The third card is limited by the fact that you have 1 and 3 out already, right?
Yeah, there's like 4.
So it's just 2 square or 4 square, right? So to add a third dimension, you only need, you only 2 options. To add a third dimension, you can, I would probably do I'll just make the box divided into 2. I'll just say 2 square or 4 square, something like that, right? So that might make it at least not confusing for me, so 2 square or 4 square with the same probability, right? So that's also nice, right? So you just do the same for the rest.
So 2 and 4, 6, 1 and 3.
Yeah. Yeah, looks good.
2, 4, again 1 and 3. So 1 and 3, that's 2 and 4.
Right. So we're being creative with the table, right? But I think it is not confusing for you. Like, I think it's being useful to you, the table, that is, right? Now, this table seems to be the equivalent in the chemistry elucidation. Seems to be equivalent with you writing all the pencils, and trying to sketch an initial structure, but mostly trying to write down in pencil. That means the step that I strongly recommend you do before you go into the proper formatting, right? Right.
Okay.
Your proper formatting feels like in DRV, it feels like your this nice thing, like in part 3, like the one above, part 3, x 3 4 5 6 7 8 probability this. That seems like a proper formatting. In the sense, the proper formatting will give you marks if done correctly. And this table, even if done right, might not give you any marks at all because it's improper, it's informal. You're saying?
I was thinking of like treating 2 square, 4 square as like one element. It's like
that doesn't make sense. What? Why do you want to treat it as one element?
Because it's like the number of 3s or 5s, and then probably get a 3, probably get a 5, and then like probability of getting
you have 3, 5, and 7, right? Yeah, then 3, 5, you can get 1, right? 1 square. 2 square is 4. 3 square is 9, and then 4 square is 16, right? So what's the benefit of you in a formal presentation combining 2 square and 4 square? What's your benefit? Like, what is their probability, by the way, even if you combine them?
Even I combine them.
Yeah.
Just 2, 3, 2, 1, 2, then 1, 2, 3, 4. Actually,
2 over 12, right? 2 over 12. Wait, how come the table is not helping you answer that question? Like, does this count? Well, the table is supposedly helping you think, so does it count?
Wait, no, it doesn't count because I can't take.
Because it doesn't happen. Yeah, it doesn't happen.
Yeah, it doesn't happen. Okay.
Right. So for 2 square and 4 square, let's say you combine them because that's one box. Let's say you desire to do that. So the probability is 2 over 12, right?
Yeah.
All right. So then I present to you, or I compare it with you. If you separate them, is it possible? Yeah, is it possible to separate them?
It'll be half times 2 12
for each, right? So 2 square is 1 over 12. 4 square is 1 over 12, right? So you seem to have no difficulty thinking about it combined or separate. That's great. I like it. That's a flexibility. So now for presentation purposes, the formal presentation, would you combine it or would you separate it?
Separate it if I'm formally presenting it.
I would agree with. I would definitely agree. Combination or combining certain things, I think, is for working purposes instead of presentation purposes. I feel like. Okay, so I believe that if the question asks you to write down the DRV table, you can. Now the question does not do that, right? Does not do that. Oh no, they ask you in part 2. Sorry, then they find you the X, and then that's done already. So if part 2 is done, part 1 is done, then part 3 is done. No, part 3 is also.
Part 3 is
Let's talk about part
conditional.
3 lah. Yeah, conditional probability. I
Actually,
like it. So you read it lah. Good. So
drawing
given that
3
he draws,
cards.
so that means what? That means come on,
That
using the
means he got
table.
even. That means he got even number.
That means the total probability is only 4 lah, right? The total,
1,
sorry,
2,
the
3,
total
4,
the total
4
possible option.
over 12.
I'm sorry. No, 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 wrong. No, 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 no. It's 4 boxes. Given that he draws 3 cards, the universe shrink. The universe shrink. So it's no longer over 12. It's now over 4 boxes, right? It can be over 4. It can be over 8 lah. Just to be fair lah. It can be over 4. It can be over 8, depending on how you see it, right? Then you just continue from there. No? So remember the universe shrinks. Yeah. Lower than 5.
Lower than 5 means 2 square, 2 square, and 2 square, 2 square, 1 square, 2 square, and 1 square.
Okay, so over how many? That means you're treating as over 8 or over 4? Which one's easier?
If it's, I think over, let's just say over 8. I mean,
yeah, easier, right? Easier, right? Good. Separation is easier. If you, then how many?
Just 1, 2, 3, 4, 4 over 8.
4 of 8, lo, done, no? Half, lo? Okay, now let's stop here. Look at the table. Like, you didn't maximize the table because the question is weird, right? But maximize the table or whatever that you're supposed to do when you're thinking about it. It helps you solve all the problems, like 1, 2, and 3. Correct. The format doesn't help you that much in terms of thinking through weird questions. Thinking through difficult questions. I feel the table or something else will be very helpful. Okay, can I leave it to you to answer? You have to answer now. You know how to do it.
Yeah, I think I can.
Okay, good. Next question.
I think that's it for math.
So
Chem is mostly I don't know. Chem is mostly just comparing back and forth, but I did have
this
one where carboxylic.
You are at carboxylic tutorial. Okay, zoom out a bit. Pinch a bit. Okay, nice.
Yeah,
Shift
it's,
to the left.
It's simple for now, but I'm finding that I have to flip back and forth a lot, and it's kind of messing.
Yeah, but you should lah. You should.
Yeah, because I was confused whether to treat this as a alcohol or a ketone.
They are both. They are both. They are both alcohol and primary. They are both primary alcohol. Look, at this point, you should have enough experience to tell that, oh, maybe primary alcohol, I need to pay attention to that compared to secondary and tertiary alcohol, right? Okay. So primary alcohol and ketone, you're saying? Chlorine. Oh, that. Okay. Yeah, you're saying?
Then it came down to, do I just say like since it's a ketone, I can just use the ketone distinguishing test and that's it? Or
you can wait. You can wait. There are already 2 possibilities already quickly. You can do the triiodomethane test, which will be positive for the right one and not positive for the left one, right?
Yeah.
Okay, that's only one. Secondly, you can do the oxidation. The carboxylic will not be oxidized. The ketone and the alcohol. Well, sorry, ketone will not. Ketone, but the alcohol will definitely primary alcohol will be oxidized. That's already the obvious test for them both.
Okay.
I'm saying this because I expect you to know them already. I was saying that.
No. Okay. Yeah. Sure.
Now, what was the confusion? Really, what was the confusion?
It was more like I have to find something that ketone would test positive for, and like I wasn't sure.
Carboxylic does not lah. Right? I suppose that.
Yeah, I wasn't sure if I should treat this as like a ketone or alcohol. That's why it's both.
Right.
So
Okay, no. It should be both. Should be both. And as you can tell, I also pay attention to the CH3 connected to CO, like the CH3 connected to CO, which is again the triiodomethane Tesla. Again, I would suggest that you will expect you to know that, but by browsing through, I don't expect you to know that from memory. No, never the expectation. But I do expect that you browse through the reaction test, not from carboxylic only, but from alcohol, ketone, and then I expect that you can, oh, this might work. Oh, that work. My feeling is that you didn't browse through that. Okay, my point is clear.
Yeah.
I go from memory because I have around 90% of it in my mind. Very comfortable. You don't have it in your mind, but that's not an excuse. This is not exam. You should familiarize yourself with the concrete list in front of you by simply browsing through, no matter how big. There isn't much. Okay, expectations are clear. You must do that. Okay, next.
I think that's. You say you wanted to get the physics?
No. Let me think for a while. So math, chem. Let's talk about chem for. Please open the URL nitrogen compound.
Oh yeah. Actually, it's chem lecture tomorrow.
Yeah. So open to the summary. Go to the end. You know what I'm going to ask you, right? What am I going to ask you?
Do you recognize this reaction, that reaction?
Most importantly, who is new and who is not new? Most importantly.
Oh boy.
Right. So the amine itself is already new. So whoa, okay. I think there's going to be a lot of new stuff, right? So ethylamine will be new, right? Go new.
He was like, is there a more built-in table? Oh boy, there is.
Oh, nice. Okay, we start from here. So the ethyl, this is it lah. This is the answer lah, right? So the ethylamine is new, right? So the center guy is new. No surprises there, right? Okay, let's go there lah. Right. So at this point, I would simply say, do you recognize anything old? Write down the new thing. Like I want you to write down that this is new. The ethylamine in the middle is new. Ethylamine is new. So because this is everything almost new, then I'll ask the other question. So is there anything old?
Yeah, this one.
That thing is old, but the CH3CN, is it old or not? Just to be clear.
That was in halogenous alkenes, the step-up reaction, and I turned into a nitrile.
Correct. So that so the CH3CN you're familiar, yes. The LLL in triether also familiar, but the whole reaction, is it new or old? That means going from reaction? Yep, from CH3CN to the, is that new or old?
I'm pretty sure that's old. Let me just check.
Just check. Then check. It would be good to check right now. Then you know, oh, it's just a double. It's very comforting to know there's a double. Very, very comforting. It's also comforting to know that, oh, this is actually new. That means you know. Right, step up. Where is the where does your note mention step up in the first place?
There we go. Here. CN.
Doesn't look like it, right? CN is involved, yeah, but
no, CH2H2.
Oh, there you go. Oh yeah. Oh, there you go. All right. So it's all good. Okay, let's do that. Okay, good. So it's all in. So the amine appeared at once, right? I suppose. There once. Right. So let's still call it new. The CH3CN, please write down O, please. Yeah, write down O.
CH3CN.
Yeah. Anything else which is O?
Here I'm pretty sure. Like I just saw it.
That seems like yeah, definitely. Okay, good. So that's how you connect the. I would say that the CH3, CH2X, that's what was the fancy word for this? A halogenal alkane, right? The halogenal alkane is your connection to amines.
Yeah.
From the old universe. So the old universe, you have to go to halogenal alkene as a gate, and then you can go to the amines, and there isn't much other way. I'm going to discount the CN for a while. because the CN kind of add or subtract C. So there's a special thing. Right? Anything else which is from the old universe?
This is acid base.
True, that might be old, but the result is new lah.
The
I
result is
suppose
new,
lah.
I guess.
Right. So old and new, so just write down. Just write down. Who is old and who is new? The reaction may be old in the concept, but the thing is new. Okay, and then COCl is also
COCl is
aerial
acyl like that.
acyl halide, yeah, acyl halide, right? So
That one was in carboxylic, which I'm still working on.
That is old, yeah, that's old.
I mean, I know it's old, but yeah,
that's old.
sure.
No, that thing is old, yeah, agree. But the product is something important to pay attention to. It contains an amide bond. So this is your gateway from amine to amide. Good. That is the amide bond. If you know that, just right, and that's new, and you need to pay attention to the amide bond. I think they want to focus on that. So go from halogenoalkane, old stuff, to amine to amide. Then the other reaction is new. That's a halogenoalkane again. That's interestingly a halogenoalkane, right?
Oh,
is it? That is a halogen. So it's good to at least mention to you that okay, at least that thing is old. Don't know about the reaction, but that thing is at least old. The product seems new, I suppose. Not sure where the new guy is going to go, but okay, it's new. So halogenoalkane. Yeah, that was new.
Just straight up amide.
Yeah. That one's from amide to that. So you can reverse from amide to amine or amine to amide. Also something important. Now, please box the amide bond. Box the amide bond since you're done that. Right. Anything else to know on all this old new stuff?
There's this.
Yeah, there's that of course lah. Right. So turns out that you can go from benzene ring. Again, benzene ring is not something easy to react, but you can do something about it. And nitrilation is a common thing to do for benzene ring, right? So you start from nitriles. And nitrile is activating, I would probably say. So from nitrile, you get more options. So the first reaction from benzene to nitrile is quite common, I would say. Right? And then from nitrile to amine is maybe what you would say the new thing. Important, so please take note. Right? So those things are, I know HCl is old, I know NaHO, but I think this whole thing should be considered new. Yeah, good. Just pay attention to that. And then from amine, you can go to, if amine is activating, then no wonder you can just brominate it. No wonder. Right? Yeah, okay. I think that thing is old. I think you should consider that. Good. Now, what is this test thing? What is this test?
For phenylamine, so I assume this thing.
Yeah. So basically, what you just went through, right? What you just went through, right? This two old thing. So the test is important. You want to test for this. Okay, fine. Right. So just please consider this new and important, but nothing else. Nothing. Okay. Right. So do you have any other summary that you have gone through? The amide should be. Nice. This amide. Okay, old, new, same thing. Old, new.
Amino acids.
Amino acids. What is amino acid, right? So amino acid starts from the center, I suppose. Right. How can you identify that as an amino acid?
I both have carboxylic and amine group.
Right. So I suppose that's why they are called amino acid. Now the name makes sense, right? Amine and carboxylic acid. If that is new to you, please write it down. If you already know that, then good for you. So amino acid, you have amine, you have carboxylic. The amine is terminal. The acid is always terminal. But the amine is terminal. So this is primary amine, you probably call it, right? Could you please indicate that this is primary amine, like 1 degree? Right? So everything else, is there anything old, right? I was expecting that everything will be new. Is there something old?
PCl5.
I know this one old. I know this one old. I know this 2 old. I know this 3 old. Okay, actually there are 3 olds. 4 olds. Actually 4. Yeah, 1, 2, 3, 4. So from NaOH to Na2CO3 to Na, all those things are O. That's just a acid-base reaction.
But
Yeah.
actually anything.
Acid with carbonates, right? Acid with carbonates.
Yeah. Okay.
So that's O. And then the Na again, of course, same thing. Those things are O. Yeah. The complexity of the result shouldn't confuse you. I say whole thing right? The NaOH same thing O just acid.
Yeah, acid and base. Yeah.
Right. So please write down OO. And then the one with Na, is it like really new? Like the one with Na first? Na.
This was in alcohol, right?
No. This is in O level. No, I'm sorry, you don't learn this in O level. Stop saying that. But this is O lah. This is just metal with. This is just metal. I mean, reactive metal with acid. Same thing lah. O stuff lah. O level lah. Sorry. Yeah, O level. Then the one with HCl. Before you go to the one with HCl, that's just O what? Because amine works as base ma. It's a base ma.
Oh yes.
Remember, amino acid means very interesting. Is base at one end and acid at the other end. Very interesting stuff lah, I suppose. So HCl just the same thing. Whole thing lah. The result also you're just a proton acceptor lah. Is it lah?
Yeah.
The remaining three, you think about it.
CH3, CH2OH, and concentrated sulfuric acid.
Oh, that's old. Right? That's old. Right? That's old. Okay, this is esterification. You're creating an ester bond.
This is from carboxylic.
Yes, bond. So box the ester bond so that you know that's why it's polar. Right. Actually, a lot of old stuff. Actually, right? Old stuff. So the reaction itself should be old. So two more, right?
PCl5. Sure.
From carboxylic to acyl, right? From carboxylic to acyl. Is that really new?
No.
No. So old stuff. Right. Last one. Carboxylic with acyl becomes.
Okay, I've heard of this before. It becomes.
Yeah, this is weirdly. There's a weirdly an amide bond there. Very weirdly, right? You see it? There's an amide bond replacing the amine. It's weird. So the carboxylic side is not reacting with the acyl. Obviously, carboxylic don't react with acyl, but the amine side is reacting with the acyl to become amide bond. Like, is this really new? This is really new.
I mean,
just flip to the page before. Just flip to the page before. When amine become amide. When amine becomes amide. Which one is the amine becoming amide? Okay, now.
CH3COCl.
Is this what's happening here?
Yeah.
Right. So everything is O. Everything is O. Which is something important and important to realize. Okay. Now, are you sure you are not confused? Everything definitely is O.
Well, there's some carboxylic stuff that I'm gonna take time to use, like esterification and like.
Yeah, check it out. That one you have to check it out again too. Yeah. Okay. So settle lah. The one at the bottom. Is there anything else there? Zwitter ion, but amino acids are Zwitter ion because of the base and acidic nature of it. Right. One is a, one N is a proton acceptor, one N is a proton donator. Yeah, one becomes plus, one negative as Zwitter ion. No? But the interesting is then amino acid can act as a buffer. This is important. I'm not sure how far they will discuss this, but there you go lah. Now, comparing the pH for a while, you notice that the pH, the strength of the acid and the strength of the base is described here as being equivalent. Right? Because pH 4 and then pH 10. pH 10 is basically POH4, right? Basically, please write it down. Please write it down. So pH 4, POH 4. Basically, the strength of the acid and the base are described to be the same, whether it's exactly the same or not, but they're actually very close to each other. So this is also very interesting. The charge is balanced. The pH strength is also seemingly balanced. They are very interesting stuff for life, I would say. Because the moment you talk about amino acids, is the moment you talk about life, it's the moment you talk about biochemistry. Okay, so let's go forward.
Proteins.
Protein is the super bio stuff lah. But before you talk about protein, you talk about polymerization. Is this the first time you've seen polymerization?
Polymerization.
Making something long polymer from something shorter. In this case, amino acids.
I don't remember it from any other of the organic topics. But
yeah, so you're supposed to have discussed this in O level and you didn't, and nobody's fault. So everything's so formation of protein is as simple as look at the top three guys. The top three guys are all amino acids. Can you see? Amine acid, amine acid, amine acid. What's the difference? The R prime, R double prime. The R prime, R double prime is what determine the type of amino acid. So do you have one type of amino acid here? Since this is chemistry, they don't care. They don't care what the R is. They just say that, oh, this is R, this is R prime. So they are different though.
Okay. So I assume the COH react with the acid
to form the amide bond. Do you see the amide bond in the product which is the protein? That's the first one, right? That's the first guy, and then the second guy will also do the amide bond thingy, right? Do you see it?
Okay. Yeah, and then water will form. So the OH from here and the H from here, I assume.
Yeah. Then you eject water. So eject two waters, lah. Simple, right? So at this point, he introduces you to the formation of protein as simply linking together the amino acid, which is really exactly what happened. That is true. That much is true. This is not fancy stuff or abstract stuff. This is really simply what's happening in our body in terms of biochemistry. We are built out of proteins. Yeah. So this is great. And then when you eat proteins, for example, meat, when you eat them, for example, milk, when you eat them, for example, tofu, you hydrolyze the protein before you can absorb the resulting amino acids. Okay, so the hydrolysis is just a fancy word for I break down the protein into amino acid, and amino acid can be easily absorbed by our body. So our body kind of takes in the amino acid to do its rebuilding project. Right? The hydrolysis from HCl with heat or NaOH with heat is your acid or base hydrolysis. Is it new or old for you?
Pretty sure it's old.
Yeah, but so do check elsewhere. Do check elsewhere.
Is the acidic or basic dependent on this one?
Of course, because it's an acidic hydrolysis, then you observe that the amine site is accepting a proton, right? Makes sense, right? Makes sense because you have extra H plus flying around. So the amino site are being accepting of the extra proton. The NOH means your acidic side is losing his H's to the OH minus, right?
Yeah.
Losing them. So and then the Na simply gets stuck to them. I guess that makes sense, I suppose. Right? Again, it makes sense to me. Does it make sense to you?
Yeah, sure. I don't.
Okay, good. Let's flip. Is your lecture at least here? Is your lecture at least here?
No, I think my lecture hasn't gone into amino acids. I think the furthest we got into was amides.
Good. Let me see the next page. Quickly. The amide, as you can tell, most of the amide, most of the no. You haven't gone through the amide chapter. Sorry, my mistake. So this is the answer. Okay, flip. Now, then this is the tutorial. So these are the same thing. Flip. Is there nothing else after this? Is nitrogen compound finished after this? Because I was expecting more amides. No?
Pretty sure it's done.
No.
There are 42 questions. What nitrogen
but they're not very difficult. They're not very difficult. The most complicated or the most difficult part is again the carbonyl and the alcohol, and you will see them time again. The third one will be considering, and you don't master it but you are okay with them, right? still complain. I still have a lot of complaints with you, but you're doing quite good. Okay, so I'll leave it to you, the tutorial.
Yeah, I need to
You
finish
still
it.
have, yeah. So we'll slightly ahead or proper in our understanding of the nitrogen, so that you can try your tutorial. Now let's go to. We have 5 more minutes. Let's go to the binomial. Let's go to the binomial.
Good. Yeah, got it.
Okay, open the binomial. So tell me where you are.
Let's see. There's a lot of like.
Where are you? Where are you? Where are you? Show me where are you. The most
so
likely.
Right.
So have you already talked about when to use the cumulative one and when to use the not cumulative one?
Touched on that, but like.
Do you understand that?
No, not really.
Okay, let's flip back. Let's go back. That one you have to understand not from the GC. GC you learn yourself. Binom CDF and binom PDF. That's it, right? What you want to understand is when to use them, how to read them from the question, what the heck does they mean. So I'm not interested in the GC. You just learn the GC yourself. The pressing is easy. Flip back. Show me. Let's start from here. Yeah, let's start from here. Okay. Now, let's stop here for a while. Let's take a deep breath and try to understand. The binomial distribution is called binomial because there are two mutually exclusive possible outcomes, whatever it is. Okay, two. Okay, two. Now let me ask you. I'll give you a case whether this is this binomial or not, or can you construct it as binomial? Okay, I'll give you a case.
Okay.
This Thursday I cannot do tuition, right? So, please create a binomial case to follow up on Thursday. I cannot do tutorial with you. Fancy words on binomial. So okay, like this. So YanKeen, hey, I cannot do tuition this Thursday. I cannot. Reasons, blah, blah, blah. So make a suggestion.
Is it binomial? I don't think so.
No. Make a suggestion on that case. Never mind binomial. Sorry. Make a suggestion. So hey, Thursday we cannot. How?
Suggestion for case.
Hey, Thursday I cannot. So Thursday I cannot do tutorial this time. How?
Wait, am I supposed to come with a case regarding this or like?
No. Like really, like let's say this is a real question. So how are you going to answer? How?
Whether you can or you cannot. I mean.
No. I cannot. Your response is.
Can I like I don't know what when to make up, I guess.
Okay. Now, let's go further. Right? Okay. Make up when?
Oh. Any other day, I guess. I mean, like.
No. Choose a day.
Okay, fine. How about Saturday then?
Okay, let's say Saturday, right? Saturday. So binomially, it's Saturday or not Saturday. Binomially, it's Saturday or any other day lah. So there are 6 days, right? There are 6 other days lah. This Saturday or 6 other days, let's just say that. There are 7 options if you think about it in terms of how many days there are, let's say. But if you think about it binomially, it's not complicated, It's Saturday or not Saturday. It's Saturday or any other day. Even though there are more days than 2, you can always construct anything as binomial. That's my claim. Understand?
So it's either like something or not something.
Yeah. It is really that easy. He put it here as success or failure. Actually, it's better to construct as something or not something, A or not A. Simple, right? So for example, your dad tells you, hey, YanKeen, tomorrow I cannot send you. I have to go to a urgent meeting in the morning. I cannot send you to school. Okay, then how? Then how are we going to proceed?
I mean, like, then I guess go school myself.
And I mean, yeah, lah, but you know, then how, right? In details.
Then how? Either I take MRT or like
Okay.
or taxi
or taxi, yeah, okay. Or
I mean,
bus? No bus. I mean, your school is near MRT.
Bus.
Your school is near MRT.
Oh yeah.
Oh,
I mean, not near, but like
no direct bus, lah. No direct bus.
yeah. I mean, okay, I have to take a bus no matter what. So I guess bus.
Okay, so MRT, bus, or taxi, lah, right? MRT, bus, or taxi. So construct it binomial.
MRT or no MRT?
No,
Or
MRT or any other. Actually, that's better, right? MRT or any other, lah. Instead of saying MRT or not MRT. Well, I mean, not MRT can mean any other, lah. As long as you read it that way. I don't want you to read it as success and failure, is my point. Don't read it that way. They are, of course, mutually exclusive. Like if you take MRT, you won't be taking taxi. In real life, you may do that if you find the MRT breaks down. Let's forget about that situation for now. We just construct it as mutually exclusive. We just construct it. Okay, that's binomial. That's binomial. Now, in this case, I'm saying that it can be applied to almost anything. In statistics, this is actually the whole thing. Statistics, not really true. This is applicable for things which are well defined. Never mind what I say. In your situation, it will be almost everything. Almost everything can be considered as binomial if you want it, not if the question want it. That's just a situation. Okay. So far, so good. Now let's look at the example. Let's go up. Go quick. Running out of time. Go. No. The one at the page. Go up. There. Okay. So binomial. The number of rand B and selection of 10 bits from a jar containing 15 rand B and 20. So I'm picking the bit one by one, right? I suppose lah. Yeah. I'm picking the bit one by one. And then it's either red or blue. Obviously, it's binomial, right? Obviously. Now, the one without replacement is basically telling you that binomial distribution, your GC shortcut, okay, your binom CDF or binom PDF does not work without replacement.
Does not work without.
I'm sorry. Does not work as a shortcut if you don't replace it.
Oh, okay.
Doesn't mean that you cannot do it. Okay, I want to avoid the if it is without replacement, you can still do it some other way, but not the binomial shortcut, the binomial distribution shortcut. That means the binomial distribution chapter is all about using the shortcut. That means you have to know when to use the shortcut or when not to. And this table is telling you. And telling you the reason why also. Doesn't mean that you cannot do it. Do you understand? You can do B, just not with the binomial shortcut. Do you at least roughly understand?
I mean, I guess I'll have to find something else, but
yeah, something else.
Yeah.
So the first bit is either red or blue. You just go with the tree but the tree has 10 branches, which is annoying but you can go with that. Understand? You can go with it. Okay, clear? So we are talking about when the shortcut applies. So C, true or false, obviously binomial. The number of students answer correctly out of 4 choices. Even though there are 4 choices, he reconstructed as correct or incorrect, right?
Or incorrect.
So correct is 1/4 as you have done, and incorrect is 3/4. So 3 choices versus 1. Correct choice or not the correct choice, binomial. That's how you construct it. E, the same thing, even though it's 6 possibility, right? I'm sorry.
No. It's like it can be potentially infinite, right?
If they phrase it that way, lah. True enough, if they phrase it that way. Yeah, the shortcut doesn't work very well. The shortcut doesn't work very well in this situation. Doesn't mean that you cannot do it. Let me re-emphasize it. The question can appear in exam, and therefore you're not supposed to see it as binomial distribution. That's what this table means. Can you please take note on B and E that way, please? It will appear in exam one way or another, and you are not supposed to use binomial. Please understand it that way. Okay?
Okay.
Right? Please write down. Please write down. Write down something like that. And our time is up. So what do we do? So I seriously cannot be with you on Thursday. Just this. Yeah, I seriously cannot. Right? Just this Thursday. Something happened. Something is going to happen. So fine. The option will be, can we move it to Sunday?
Actually, I was thinking we could move it to, okay, so Friday. Oh, can you do on Friday? Friday is like a public holiday. And like,
yeah, that means Friday morning.
Yeah,
that means Friday.
You could do it on Sunday. I don't mind. Like extended.
Yeah, extended or two or earlier and later also can.
Yeah, that works too. I mean, Sunday nothing much going on.
Right. So my Friday is also full again because of the holiday.
Yeah, definitely.
Yeah. So let's try on Sunday first, and let's try the earlier and then the later one, and we'll just finalize that before. I think I'll finalize it on Thursday or tomorrow.
Yeah, then just tell me the time, then I'm sure.
Right. Now, what's the expectation? So I'm giving you a Sunday expectation. Same thing, honest questions. That means we don't spend time doing them. We spend time answering the question that you have already, right? And then we should try to get, because this is a holiday, right? So you'll be slower a bit, right? I hope your teacher is not doing crazy things like, it's holiday, I'm gonna hasten things by asking you to study more lecture. No. Is your teacher gonna do that?
No, we have to prepare for CA, which is next week.
And what are the topics of the CA?
I believe for physics is wave motion and superposition. So
right. Okay then.
And then math is the probability and PNC.
The first two, right? Okay.
Yeah. But math is like pretty sure math is on Thursday.
Like which Thursday? Which Thursday are we talking about?
The coming one.
Do your best, lah.
I'm gonna be honest.
I mean,
I've been doing questions on the side, but you know, I honestly I think I might be fine, like, especially for probability.
Right. I don't think you will have a big problem. The question will always give people a problem. If you already expect that, then you're at least mentally shielded from, being morally down. The question will always give you trouble at the end, not at the start. So you can always handle the stuff. If you use the proper techniques, if you prioritize thinking, working out things instead of presenting things, if you prioritize that would be great.
Okay, and then chem is on Tuesday, and we're doing oh boy, we're doing hydroxy and chemistry of aqueous solutions and acid base.
KW, KA, KB, and hydroxy.
Actually, let me get an exhaustive list. Give me a sec. I have it here. Chem for no, that's where is it? Is it my picture? So I give it like no, that's yeah.
It's too unrelated to the future chapter.
Yeah, but you know, where is it? I can't.
So do you have extra practices?
Yeah, I do have some, like actually yeah, I do have like for chem and physics, the superposition one, the one we discussed last week. What about no? Was it last week or was it Sunday?
That means you still have practices lah. You still have extra
yeah.
practice. Okay, if you have them, then okay, let's agree on this. You're gonna ignore the future chapters. You're gonna prioritize the exam, right? You can only do one. You can only do one properly. Like either you prioritize the future stuff and you ignore the exam, so to speak, just rely on what you have done, or you do it the other way around. You don't try to do both. It's fine. It's fine.
Yeah.
Right. So that's my only requirement. You can choose lah, but you cannot do both lah. Which one do you choose?
At least for like the Good Friday holiday, I think I should focus on.
I mean until the CA is done. Really, I don't mean just one day. You cannot study subject in one day, please. You cannot. Please don't do that.
I mean, for like the 3 days, like the Sunday,
Friday, Saturday, Sunday, but with at least 1 day break. At least 1 day. At least 1 day break. Then you can go all out.
Yeah.
But anyway, which one do you choose?
I think until CA2 ends, which I'll be honest is not that far away.
Yeah, I know.
And then I think I have to focus on the revision, especially for aqueous solution, some of the KSP.
Yeah, because you have forgotten that, right? So for this Sunday, I won't be asking you to finish the tutorial or go ahead lah. I won't. So I'll just be asking you, have you done the exercises for the CAs? And then let's answer the questions from there. And then it will be a good Sunday. Okay. Right. So no need to do the RV, no need to do binomial, right? No need to do amines and all those stuff. No need for now. I'll help you catch up later on.
All right.
Okay. See you on Sunday. Bye.